All right, next up we have the tangent graph. So let me once again go ahead and start with the midline. So I'm going to look at the middle line of this graph, and that is right here. Okay, and once again, we just write the equation of that. It's y equals 0. Now the amplitude, this is kind of a trick question because we don't really have a highest point or a lowest point. Wait, our graph continues to increase or decrease towards positive or negative infinity. So this is actually kind of a trick question. You could talk about the amplitude as being 1, but most of the time what you're going to see here is that there is not an amplitude for your tangent graph. The period of the function. So once again, we've got to look at starting the graph off, so finding a beginning point. So this can also be a little strange. So I'm going to actually start at 0, 0. And what I notice is that's the middle of one of those kind of weird looking, almost cubic shaped graph piece of this tangent graph. So I'm going to trace from there. Okay, I go up here. And then I have to pick up on the other side of the asymptote, and then I'm going to stop when I get back to where I began, which is on the midline. And that would be where I would put my red dot. Now, the length of time it takes this time to finish one cycle is pi units. So the period for our tangent graph is a little bit shorter. Once again, hopefully you're getting a little bit better at these x-intercepts. So the x-intercepts, if we just identify a few of them, we would have 0, 0, we would have pi 0, and then 2 pi 0, and so on. And each of these are separated by pi units. So to get our kind of generic form, we're going to say 0 plus or minus pi times n, 0. That's going to be our generic form of the x-intercepts. And then finally, not finally, but one of the last two things, we have our y-intercept. That's pretty easy to identify. But this is the one that we want to think about as well. So our asymptotes, I'm going to write a couple of the asymptotes down, and then we're going to think about how we can kind of do this in a generic fashion. So one of my asymptotes is x equals pi over 2. Another one is x equals 3 pi over 2. And then we could kind of continue, but I want to look at these two and see how far apart they are. And once again, these are pi units apart. So what I can do is I can say all of my asymptotes are going to be of the form x equals pi over 2 plus pi, and then again use some integer n to represent different multiples of pi. And you can do plus or minus if you like.